Hello everyone! How's everyone doing? Alrighty, today we're gonna take a first look at the Zig language. I kind of wanted to do that for a while, and I was wondering, should I learn C or should I learn Zig? And mostly from the perspective of what will teach me more about low-level programming and overall how computers work. So after some research, I learned that, hey, Zig might be a good thing because with C, I might go into the situations where I'm not as much learning how the computer works. I'm just fighting with the fact that, oh, I forgot this, I forgot that, and I'll be hunting bugs. While with Zig, hey, you forgot about this, you forgot about that, so I'll learn, first of all, a little bit better. It'll be a little bit safer and easier to learn, I think. And at the same time, we're going to have some modern features that will keep me a little bit more engaged rather than, good old C. So yeah, let's take a look. So first we can look just overall at the main website for the Zig language. So yeah, Zig is a general purpose programming language and toolchain for maintaining robust, optimal, and reusable software. So I did use Zig as a compiler before, not to an extent that I would be, understanding what I'm doing. But I heard that Zig is often used by C programmers just to compile their C code, because I guess it's a little bit more reliable or something, or just easier to use. So it's interesting to see that it's also a general purpose programming language. What do you mean by general purpose? As in not specialized in just web server, just systems, just something. It's just for everything. I guess that's what they try to mean. And of course, it's a toolchain because you can do your C, you can do other stuff. So we're just gonna take a quick look at the main page, and then we're gonna jump into get started, set up, and start doing some exercises. So a simple language, right? The focus on debugging your application rather than debugging your programming language knowledge. Okay, I like that. So first of all, no hidden control flow. That's what I heard. What you see actually happens, nothing behind the scenes. So this is like 180 opposite of some of the languages that try to abstract things away as much as possible from you, where you think you just said something, but 10 other things happen, right? Then we have no hidden memory allocations. Okay, you need to do everything. And no preprocessor, no macros. So I guess this is an argument for simplification, that again, no magic is happening before, and there are no macros as in real pain to write. But because instead of that, they have comp time, right? A fresh approach to metaprogramming based on compile time, code execution, and lazy evaluation. So I think by now everyone heard great things about comp time. So that's kind of fun. Call any function at compile time. How real is any? Because that's interesting. Manipulate types as values without runtime overhead. Okay, that's great, because how many times one just doesn't want to copy paste types? If you can kind of generate them for yourself and they will end up being actual types without anything happening during runtime, that would be great. And compile time emulates the target architecture. It emulates it. Oh, that's interesting. That's right, because during compilation, as far as I know, with Zig, you can, you run your code on Linux, you can compile it to macOS, to Windows and whatnot. And if you have some code that is supposed to run during compilation, it actually needs to emulate a bunch of stuff. Like, I don't know, file system operations or something. That is very interesting. I wonder how far the comp time goes. What the limits really are. All right, and then you have maintain it with Zig. Incrementally improve your C, C++, Zig code base. So use Zig as a zero dependency, drop-in C or C++ compiler that supports cross-compilation out of the box. Yes, so that's what I heard. That, hey, you don't have to use Zig programming language, just use it as a compiler, right? Then you have leverage Zig build to create a consistent development environment across all platforms. Okay, so that's probably the part of the toolchain, right? And then we have add a Zig compilation unit to C, C++ projects, exposing the rich standard library to your C, C++ code. Oh, so you can actually use parts of your Zig for your C++ projects. Okay, this is fun. So let's take a peek at if I can actually make any sense of this. Because disclaimer here, I don't know much about low-level programming, and the whole goal here is to actually understand it. So I'm predicting that there will be situations where, documentation or examples talk about something. I have no idea what that is, and I need to go and learn that first. Or like, why is this happening? Why are they assuming I know this thing? All right, so we have constant standard is import standard. Oh, that's very interesting. So import libraries just like variables or constants. Interesting. Constant parse integer, we have standard format parse int. So I guess this is the example that we can, wait. Oh no, this is, so we're extracting a function from here and we just have it available as parse int. All right, I get that. So I guess there's no such thing as, hey, import everything and make it available within this file. We actually need to always qualify it or extract it by the means of, hey, I'm gonna do it as a constant. So I presume one could just throw it somewhere inside and reuse it from there. Okay, that's good. And, this is a test. So test parse integers. Okay, so we have some input, which is, I guess, what the hell? 1,236,789.99. What is this? I mean, this is a comma, so it's probably not even a point. This is just 123 million and whatnot, right? There's no floating point here. I guess that's an example, right? You can do weird stuff. Constant GPA, standard testing allocator. Okay, so we have testing allocator. All right, to allocate memory, I guess. And then we create a list. So this is variable. Again, from standard library, we get the array list of UN32. So unsigned integers, the standard ones, and we initialize it using the allocator. So I guess this is the part of no hidden memory allocations, right? We explicitly register memory for this array. Oh, I see. So I guess the whole idea here is that we initialize the array with this allocator. So whenever we will request some, elements to be created, this allocator will be used to allocate that memory. Okay. Okay. So ensure the list is freed at scope exit. Try commenting out this line. So we have defer. Okay, beautiful. We have defer list dinit. So I guess this will clear its own memory through that allocator. And okay, that makes sense. So I guess we don't have a situation because they're suggesting that this will fail due to some reason. Like, I mean, if we comment this out, this will fail. That means that if we created this allocator and it goes out of scope here, I guess it won't just deallocate all the memory. It doesn't keep track of it. We need to do it for the list and whatnot. Okay, I can live with that. So what's next? Another variable. IT. Standard memory tokenize any. Hmm. Okay, so I'm not sure what this does, but we get uint8. We give it the input, which is this string. And I would expect that wait, tokenize. Does it mean that it just removes spaces and commas? That's what it does? But what is the integer then? IT will be iterator, I guess. So we're going over the iterator. So we have a concept of iterators. That's awesome. And hello, CPN. How are you doing? CPN says it creates an iterator. So tokenize is just random name for generating so this is for generating an iterator over a string. And this is maybe characters that we're supposed to ignore. I mean, we'll get there. We'll get through documentation. We'll learn that, I'm sure. So we go over all the entries in the iterator. I guess this is how we are specifying that this is where the next element goes in. And then we do try parse integer as uint32. We take the number that we just, I guess this will be our, so U8 is just basically a single character, ASCII character. That's what each token will be. And therefore here's our token. And we just parse it, I guess, into a number. Oh, that's what we did. So now I get it. Okay, so this is not one single number. This is supposed to be one number, second number, third, and fourth. So we did split it by commas and spaces into tokens of those characters, whatever that is, really. And therefore, here we are parsing them one by one as a base 10 number. And then we basically append the results to the list. Okay. So CPN says num will be a slice of that array. Okay. So we're dealing with slices here. Okay. That makes sense. So I guess I presume by this point, if they're showing this off here, that slices are like the bread and butter within a standard library. Okay. And then we have expected result, which is, I guess, a list or something. I don't know. Maybe an array, like a constant array, right? Because the list is definitely not constant. This can grow over time, just like we're appending elements here, so it dynamically grows. Well, this, I presume, would be just a static array of those U32 numbers, and we're actually expecting to get those here. And then for each expected and list.items, so I guess .items will give us a static array. And we get the left and right. Okay, so this is like iterating over two elements at the same time. Okay, we get left and right. That's great. And we are using testing, expect equal, and those two numbers. Okay. Very different, but at the same time, I feel like this is way simpler than what C code would look like. I think way simpler. We just have a few interesting features here. Okay. Yeah. Great. So, I mean, there's more code examples or like, what is full overview? This will be just feature highlight, but it just shows us a bunch of code, compares it to C. So this would be nice if I already had lots of experience with C language, then maybe the overview would work. Instead of that, let's just go to get started. I hope this will get us through some kind of examples and maybe step by step how to learn it. So in getting started, we have tagged release or nightly build. Zig has not yet reached 1.0, and the current release cycle is tied to the new releases of LLVM, okay, which have around 6-month cadence. Okay, so every 6 months you update stuff. Not too bad. In practical terms, Zig releases tend to be far apart and eventually become stale given the current speed of development. It's fine to evaluate Zig using a tagged version, but if you decide that you like Zig and want to dive deeper, we encourage you to upgrade to a nightly build, mainly because that way it will be easier for you to get help. Most of the community and sites like Zig.guide track the master branch for the reasons stated above. Okay, so that instead of having big upgrades every time, you just gradually continue. Okay. The good news is that it's very easy to switch from one Zig version to another, or even have multiple versions present on a system at the same time. Zig releases are self-contained archives that can be placed anywhere on your system. Okay, so installing Zig, direct download, Windows, there we go. Linux, but we have package managers. There's no package manager for Linux. There we go. And many package managers for Linux. Okay, so I actually did install it already. I did go into Zig, and we can see that right now it's this one, version 0.14.1.2. I wonder if this is nightly or something. This is already version 15. This is some kind of development version. Then you have nightly bin, but these are all the stuff that is this really official? Maybe we'll switch to that. For now, I think I'm just gonna continue with 0.14. I don't know what was added into 15. Can we look here instead Zig from a package manager? Okay, so we have tons here, right? We have Arch Linux, just a Zig, so they don't specify that this is which version is the nightly. Yeah. That's it. Great. I already have that installed. See a repository for an overview of which package management system and operating system has already been packaged for. Okay. So we have versions. Arch. It's all Zig. And then we have dev bin. And Zig bin and Zig git. There's nothing mentioning the, what do you call it? There's nothing mentioning nightly builds. Okay, so I won't trust those. And CPN says, yeah, stick to version 0.14.1. Let's see if I just totally bounce off the language. It's easier to just download the banners directly. Okay, I see. All right. So we've got our Zig, and we installed it. So now will be recommended tools, syntax highlighters, and LSP. I think my VS Code already took care of that, so we'll see how that goes. And then we have run hello world. If you completed the installation process correctly, you should now be able to invoke the Zig compiler from your shell. Let's test this by creating your first Zig program. Navigate to your project's directory and run. Okay, so we create directory hello world, go there and do Zig init. Okay, so I created a little project. As a project, I mean empty directory. So let's do like directory, hello world. Zig, let's go Zig init. What does it do? Create a build Zig, create a build Zig zone. Lots of Z's, that's for sure. And then we have source, main Zig, root Zig, and Zig build help for menu options. Okay, so we've got some stuff already. So we go to, I mean, that's all here, right? Yeah. So we did that. This should output, bam. Running Zig build run should then compile the executable and run it. Okay, Zig build run. I mean, let's see what code we're going to run. So we got main. By convention, main Zig is where your main function lives. In the case that you are building an executable. If you are making a library, the convention is to delete this file and start with root Zig instead. Okay. These are interesting comments with exclamation marks. Is that a notice because we have normal ones? Or maybe documentation or something? Interesting. So we have our main, which will print to standard error. Okay, so standard debug print. All your code base are belong to us. Okay. Standard out is for actual output. Yep. So the file writer. Wait. So we get our standard out file, which will be standard IO get standard out writer. Okay, so we'll just write to the standard output file, which is whatever stream. It's fake file. At least on Linux. How does it relate to Windows? I don't know how that works on Windows. So then we have binary writer or something, buffered writer. Okay, so we create a buffered writer into the standard out file, and then we just create a writer again. Wow, this is several steps. Okay. And then we'll do print run Zig build test to run the test and try to flush it, right? There we go. And then we have test and another test and test. And at the end, we import standard library and we import. This imports the separate module containing root Zig. Take a look at build Zig for details. Okay, so we just import this as library. What for? At the end. Interesting. Because then we have the root and CPN says it's the same for Windows. Okay. I mean, I assume that the code is the same for Windows. I'm just saying that I don't know how Windows handles that. And that buffered writer step is not necessary. Okay, we'll learn about it. And this is the root, which is like if you were doing library. So the root source file when making a library, if you're making executable, the convention is to delete this file and start with main Zig. I mean, if we're going to delete it, this will probably start complaining, right? Because I don't know, or maybe not. Export add, and we have some basic add functionality, right? Okay, so let's run let's run the code that they wanted. So this would be simply Zig build run. Okay. Zig build run. Okay, it's compiling and all your code base are belong to us. There we go. Beautiful. And we have Zig out, which has our binary. Okay. And an A file, which is something. Okay. This is great. And then what else? So we can actually take that suggestion, right? Zig build test. So Zig build test. That didn't do much. Do we do build run test? To run the test, unless maybe there are no errors. So our main Zig, why is it like not Zig-like? Am I missing something? Zig. Zig language. There we go. Zig language server, yes, please. Oh, now it looks properly. And A, this CPN says .a means static library. All right. Oh, as an output, interesting. Is the A like Zig only convention? Because static library, oh no, static library. That can be, I guess, compiled into something, right? Because .so is a dynamic library. So, okay, that's new world for me. Alrighty. So what was in our test? Simple test as some kind of array of stuff. And we have defer the init. Try commenting this out and see if Zig detects the memory leak. So yeah, let's try that. It's the same as the other time, right? Let's say we don't defer it. Zig build test. Oh, look at that. So build summary, 3 out of steps succeeded, 1 failed, and 4 out of 4 tests passed. 1 leaked test. Okay. And this is run test 303, 1 leaked. The following build command failed with exit code, and we have no other details. Main test fuzz. Oh, of course, I'm starting to read from the middle. That's what I get when the font is so gigantic. You don't even know where it started. An array list is used if you want dynamic array. Yep. It's probably just a linked list or something of the sort, or list backed by a set of actual arrays or something. Yeah, probably just arrays. It probably just copies memory and expands them over time. And hello, Vicky's art. What's a Zig? Don't know what a Zig is, but Zig is a programming language. Very low level, like let's call it competitor to C. Okay, so the test leak. So it says main.test.simple. So I guess main as in a file, and .test that it's a test, and then we have where it go? Simple tests. So I guess that's it, right? Okay. It even says which memory address leaked and that it's related to the specific allocator. Okay. And ensure total capacity. So this is some internal stuff. Okay. All right, lots of stuff. So I guess the first 2 lines are helpful, the rest is not. Okay. So well then the following test command failed. And okay, so we just get info roughly what happens, and that's pretty much it. I guess that's good to even get a warning about memory leak, so yeah. Awesome. And Tom, hello Tom, can you do a quick recap of what you've done so far? I installed Zig, read through the like main page, and did Zig init to literally get those bunch of files. And it looks like main file, the main.zig in sources is like when if you have an executable, it basically, that's what gets executed. And if you're making a library, you run the root. And what we did so far is literally zig build run, which run our code. And then we did zig build test. We also broke 1 test by doing this, and that's pretty much it. So let's get back here. And Vicky says, I'm zigging to understand. You're a software engineer or not? That's the question. Congratulations, you have a working Zig installation. Beautiful. Next steps. Check out our other resources present in the Learn section. Make sure to find the documentation for your version of Zig. Okay. And consider giving zig.guide a read. So where do we go? Learn or zig.guide? Which one? I guess we'll open both in the background. And Zig is a young project. Unfortunately, we don't have yet the capacity to produce extensive documentation and learning materials. Okay, so you should consider joining one of the existing Zig communities. Great. Finally, and there's some Zig Showtime, whatever that is. Finally, if you enjoy Zig, you want to, consider donating. Okay. All right. So we opened up 2 pages. The Learn Zig and Welcome to Zig Guide. And Zig Guide talks about version 0.13. Okay. We have 0.14, so this is kind of outdated unless, there's 14. Not exact 14, but a little bit better. Well, here we have the documentation, which is either unstable or latest stable, which we have. So we have language reference and standard library documentation. Okay, so I guess we'll need to have both open for just in case, and then we have guides. And Vicky says, lol, no, just no Java. Okay, so consider this being a little bit lower level, like C++, C. It's just a newer language with different approach. And disclaimer here, I'm not a big low-level guy. I'm using learning Zig as a tool to learn low-level programming. At least that's an intention. We'll see if I survive. Okay, and then we have guides, which is mostly about the Zig build system. We're not gonna go that far. Let's just learn about Zig itself first. So introduction, these are all introductions to Zig aimed at programmers with different backgrounds. So we have in-depth overview of Zig from a systems programming perspective. So the thing is, I don't have the systems programming perspective. That's not something I'm used to. Then we have why Zig when there's already C++, D, and Rust. Okay, so this is for these people. Then we have code examples, a list of snippets to get a feeling for how Zig code looks. Okay, and tools, a list of useful tools that will help you write. So I guess none of those is for me. And then we have getting started. If you're ready to start programming Zig, this guide will set up your environment. We already went through that. And then we have like other resources like project-based book, an open technical and introductory book for Zig. Ah, I like that. And then we have Zig guide. So I guess that's the thing that we have open. Ziglings by fixing tiny broken programs. That could be fun. We have Zig on exorcism. I don't like that platform that much. And then we have learning Zen, short introduction. Okay. And then videos. Well, we won't be watching videos while I'm kind of making video. So let's see what we got here, right? We've got our full-on documentation, which is, tons. All right. We had our hello world command, values, Zig test. Okay, so this is just straight up documentation going through everything. This won't guide us to learning. And then we have standard library. Okay. Then we have the Zig book. Last update 3 weeks ago. Okay, that's not bad. Vicky says, is this for fun or for work? This is, let's call it for fun. But at the same time, I'm actively improving my knowledge. So we'll translate to work. Okay, so we got the Zig book. CPN says Ziglinks is really good. It's like Rustlings for Rust. Didn't go through Rustlings for Rust. But I know that I like books. An open technical instructor book. So it's technical. I like that. This is the official repository for the book. The core book content is built using something. And do we have roughly... So this is open technical introductory book for the Zig programming language, which is a okay. Yep. It's designed for both beginners and experienced developers. It explores the exciting world of Zig through small and simple projects, in a similar style to the famous Python Crash Course book from Eric Mathis. Some of these projects are a base64 encoded decoder, an HTTP server, and an image filter. Okay. As you work through the book, you will learn the syntax of the language and how it compares to C, C++, and Rust. Oh, I kind of like the comparison because I have a little bit of familiarity with C++. I touched Rust once, twice, but not for long. Data structures, memory allocator systems, optionals as new paradigm, how to test and debug, errors, how to combine C and Zig, and parallelism and SIMD. Okay, all right. And how to, you need to build a book. I did not expect that. You need, we need Zig, you need R, and you need Quadro publishing system. Okay, I did not expect to do that, to be honest. Is there a release of the book? There are releases. And it's in the format of source code. I am confused. It's available here, but otherwise I guess you need to build it, and that's pretty much it. Don't feel like doing that. And Vicky's Art says, I'm gonna go sleep, have a good study session, and great night. Thank you. Have a great sleep. And SPN says, I thought this would be a PDF. I guess it would be too, but I think here is the paywall. Either buy the book or go straight from the source. I mean, if the source would mark down, I would like that. Chapters. Whoa, this is QMD, which is it's readable. I can live with that. Looks just like nearly like Markdown. So in theory, we could just throw it into Markdown and call it a day. There's lots of text, so I like it. But before we jump into that, I want to look at Ziglings and the Zig guide. Tom says, for us higher level programmers, the insight I got from AI was that Zig has metaprogramming via comptime, which is like compile time programming that allows generics and stuff, but a compile time. Yes, definitely. And I heard a comp time is awesome. So you can basically run any kind of Zig code during runtime. So if you want, you can generate files. If you want, you can, I guess, even do HTTP requests. That's what I would expect personally. That would be fun. Or you can just, generate a bunch of code, maybe types and whatnot, and it all magically works through, what happened here? And it all just magically works through things. Somehow. Okay. So that way better than C, I guess. Oh yeah, with C you have macros, and that's real pain. They're complicated, confusing to write. You need to learn an entire separate language to write the macros, which is way more complicated than C itself. And here you can write your macros in normal regular Zig. There's no extra fancy syntax. And Spen says, click that link in the About section. And the About section... Wait. Where did I get? Ziglings. Donate. About. Why can't I go back? Because it opens every time a separate thing. Okay. So you're saying to click something in About section. Which website are we talking about? In Zigbook? Okay. So I see that in Zigbook. About section. I mean, that would be just linked to this page. Oh, no. Oh, all right, all right. For some reason, I saw GitHub and I thought it links to itself as a page. Sorry about the pure white, but oh, okay. Looks like the book is readable here. It's very, very long, so it'll probably take a long time. What do we have? Introduction, we have control flow. Okay, so okay, it's definitely not complete looking at that because we have some. I mean, we have some projects. How long are they? Not long, that's for sure. I guess we have source code and figure everything out yourself, or somehow it's actually good enough. I don't know. But what about the Ziglings? Where did they go? They disappeared. So where were they? I just want to see the format of those Ziglings. No. Ziglings. Welcome to Zigling. This project contains a series of broken programs and one nasty surprise. Okay. So intended audience. This will be probably difficult if you've never programmed before. Well, we did, but no specific programming experience is required, and particularly you are not expected to have any prior experience with systems programming or a systems level language such as C. Okay, I like that. This is good news. So each exercise is self-contained and self-explained. However, you're encouraged to also check out the Zig language resources for more detail. Okay. So getting started, you get the Zig. They recommend version 15, I guess. So development build, yep. Clone the repository, and I want to see what is in that repository. Oh, this is like not the GitHub one. Interesting. Versions. Okay. Okay. And we have like a list of exercises. What's covered? A large amount. Okay. So how about we start with like 2-3 Ziglings or whatever. We'll see how long it takes. And then I'll also do a little bit of the other stuff. So you probably don't care, CPN, about a link to Ziglings, but I will also send you the link to that fun book. And we'll see how that goes, all right? So let's try the Ziglings. I'll ignore the guide. I'll ignore the other stuff that exists here. So to check out Ziglings for a stable release of Zig, you can use the appropriate tag. Zig is under active development. Tracks development builds for the Zig compiler rather than version release builds. Okay, I see. 15.0 dev. I recall that we had access to the dev version, right? So let's do yay. What was it? I forgot how to uninstall. Uninstall. I think it's just capital R, right? Capital R is remove. Okay, so let's do something drastic. Zig, capital R. Wait, not yay, remove Zig. Okay. And then we're gonna install the development version. I had the 14.01 or something like that, 14.10. So now we're gonna do yay Zig, and we'll see those versions here. So I had this one, but what we need is this one. I'm not gonna go into nightly, whatever that is, but this one we're gonna go with. So it'll be number 6. Yeah, whatever. That is not a lot of installed stuff. Mm-hmm. Good. It's a good place to download it. Okay, now we're talking. Now it's a proper size. Okay, so Zig version and wait, Zig version. Oh, just like that. Okay, there we go. Okay, we're good. We've got a new Zig. We can go on and get our Ziglings. So let's go to temp Zig. Okay. And this will probably just create a new Ziglings directory. There we go. And we've got exercises, images, patches, tests, tools. We have entire build here and readme. Okay, so I guess we'll be just fixing them and doing stuff. So we'll close this one, we'll be in here. Yep. And we got in there and then run zig build and follow instructions to begin. Okay, so this is interesting. I guess it will be guiding us through fixing stuff. I wonder if I should just have a separate terminal here on the side or something. I just really don't know what is a good size to have my VS Code for the stream. So and zig build. And there we go. Error, member function expected, 5 arguments, found 3. Okay, so I'm just supposed to keep going like that? Step zig, function declared here. Okay, so I'm supposed to go to, wait, this is not in my code. What is mine? Build.zig. So we start with build.zig, line 522. This is a fun way to start with an error, or it's probably not what I'm supposed to. After many changes in Zig build system, we need to create the cache path manually. If there's a better way in the future, I don't think I was supposed to be here. CBS says, forget what the website says, go to exercise directory. Okay, I see. So we have exercises, our first hell zig, and I guess we'll just jump in here and run them one by one. Okay. So, oh no, this is supposed to print hello world, but it needs your help. So I can probably do zig build. Can I just specify 001 hello world? Okay, member function expected, and this is pointing me to build.zig again. Oh no. Something ain't working. But looking at it here, we have standard, import standard. Okay. And then we have our main function with debug print hello world, new line, and no arguments or something. And Spin says random by zig build exe file name zig. Okay. Zig build, whoa. exe. And we do 001 hello world. Oops. These are creeping in everywhere. Okay, so we're getting something now. So we have error. Main is not marked pub. Okay, so it's not public. Okay. So, oh no, this is supposed to print hello world, but it needs your help. Zig functions are private by default. Great. But the main function should be public. A function is made public with the pub statement, like so. Perhaps knowing this will help solve the errors we're getting with this little program. Okay, we just do pub function main. It'll print hello world. We can even change it up and it should still work, right? Didn't print it. Hello, Taras. What's up? Okay. So this just builds, doesn't run it. SVN, sorry, easier way to run is Zig run file name. Okay, so we don't need to do the build, we just do Zig run. Okay, that would be great. 001. Oops. Hello. Oh, okay. Dot Zig. Okay, we got hello cruel world. This way we won't have to move. Hopefully we won't have to deal with the executables everywhere, right? Okay, we didn't get executable this time, so that's great. Okay, so we can move on. We learned that, okay, we need to throw in pub in front. And we have 110 exercises. All right. So let's go on to the second one. And Tara says you have a bad choice for file names. Which file names? I didn't create any. These are all exercises. So let's try the 002 before we even do anything. So this, okay, so I get a nice clear error. I don't have a bunch of this extra stuff. Okay. So let's read. Yeah, this is just Zigling's exercises. They are supposed to just guide you one by one. The whole idea is that you learn the language by fixing little programs. So just a bunch of tutorials. So we have, oops, this program is supposed to print a line like our hello world example, but we forgot how to import the Zig standard library. The import function is built into Zig. It returns the value which represents the imported code. It's a good idea to store the import as a constant value with the same name as the import. So constant foo, import foo. Please complete the import below. So we want to store the std as a constant, right? Already we get an idea that this is a type, so import, oops, come on, import during compilation time just takes a string and returns a type. This function finds a Zig file corresponding to path and adds it to the build if it is not already added. Okay, so we don't have to do any pragma once, other stuff. It will just add it once. The Zig source files are implicitly structs. Okay, with a name equal to the file's base name with the extension truncated. All right. Declarations which have the pub keyword may be referenced from a different source file than the one they are declared in. I guess we can kind of re-export them, right? Okay. std, there we go. Now we have this, so we can do standard, we can use that standard, right? Debug, print, and standard library, right? So we save it, and now we can run it and beautiful. Works. And Tara says you decided to to dug everyone's brain before sleep. I don't know. I just have hard time focusing today, and kind of figured on stream will be easier. And Tara says, "Okay, bye. Bye." We're not doing any difficult stuff. This is just basic tutorial, unless I'm just following them in such a way that it might duck your brain. Okay, for the curious, imports must be declared as constant because they can only be used at compile time rather than runtime. Zig evaluates constant values at compile time. Don't worry, we'll cover imports in detail later. Also see this answer. Okay. Let me open it in a proper browser, not in some other browser on the side. Whoa, that's very white. That's a lot of pop-ups. There we go. Struct definition with var instead of constant in Zig language. Struct definition with var instead of const in Zig. I'm now learning Zig language. I have seen definitions of structs with const keyword like this. Const x is struct this. My understanding is that const is a kind of complementary to var. The latter allows change, the former does not, but what would mean defining struct with var? Is this legal? It compiles, so yes, but what's the meaning of this? Okay, so that compiles because Zig is lazy evaluated. Okay, because y is not used, the compiler doesn't check it. Oh, okay. When you reference it, the compiler throws an error. Var y struct bam. Oh, all right. Very interesting. So just straight up remove your code in the meantime. I don't mind that. And so we have this, and then we have comp time. I mean, that's trying to do in compilation time, so variable of type must be constant. What if you try to use it not during compilation time? Var is to declare variables. When you use var in a global scope, that creates a global variable. In your case, bam. It declares y as a variable of inferred type. In this case, y is a variable of type. In Zig, there is no comp time only types. That is the case of type. A value where the type is comp time only type only can live inside the compiler. You can't create the value in runtime. Okay, so basically don't have type during runtime. So the compiler needs always to comp time known the value. So because y is a global variable, you can modify it in runtime. That is the reason for the error. Okay, we'll get there. This is kind of confusing at this stage, I think. Not this. What the heck? This. Alrighty. So fix this one, no big deal. Let's go on to the number 3. It seems we got a little carried away, making everything constant U8. Constant values cannot change. U types are unsigned and cannot store negative values, and 8 means type is 8 bits in size. CPN says the tutorial itself is throwing you in tangents. Lol. Yep. Example, foo cannot change. It is a constant. Bar can change. It is a variable, right? Simple. Example, foo cannot be negative and can hold 0 to, 255. Bar can be negative and can hold 128 to 127. Okay, so we have unsigned and signed. Simple. Example, fold can hold 8 bits and 16. So we have U8 and U16. And that's simple. You can do just about any combination of these that you can think of. So if U32 can hold BAM, I64 can hold that. Yep. Please fix the program so that the types can hold the desired values and the errors go away. So great. We have our STD and constant n. U8 should fit it. If no. What? I thought we were supposed to just fix the program, right? So we don't want it to be constant. We want it to be variable because we are changing it later. Pi is U8. No, this will be not even U16. This needs to be U32. Negative 11. So it won't be U, it will be I. And then we have print all those values, and I guess it should work. Okay, this is simple. There we go. Worked. And CPN says, I gotta go now. High five. All right. Have a good day/night. And never remember. Alrighty, so let's go to 004. Okay, they're becoming more and more text. So let's learn some array basics. Wow, we're jumping into arrays. Okay. Arrays are declared with, so we basically variable foo, and we have, I guess, size 3 of unsigned 32-bit integers. Okay, so we have so there's a colon here. So basically we can specify a variable foo of type this, which is, and we again specify this type with brackets, and this I guess it is a notation to create a new instance of that array, and we give it 3 values. Okay, that makes sense. When Zig can infer the size of the array, you can use the underscore for the size. You can also let Zig infer the type of the values, so the declaration is much less verbose. So yeah, we just do that. We don't even need to, first of all, we don't need to specify that there are 3 elements here. And on the left, we don't need to specify at all because this is very clear that this is an array of a number of U32 integers. Okay, so get values of an array using array index notation. So this is standard, right? Standard like in so many other languages. And then we have set values of an array using array index notation. So we're setting it, great. And then get the length of an array using the foo.len. Yeah, the len property. Okay. So I want to see how it works in practice. If, let's say, VS Code is smart enough to actually suggest things for us. I mean, we have language servers, so it should be fine, probably, right? So problem 1, this const is going to cause a problem later. You can see what it is. Yeah, can you see what it is? How do we fix it? So constant sum prices, and this is U8 of bunch of numbers. There's no problem here. All those numbers will fit. It's a number of them. It inferred that it's 8 elements. Okay. But then in the next line, we have the problem, right? This is going to be, we are trying to set a value of that list or array, sorry. And therefore it'll be a problem because it's const. We need to do a var. There we go. If I have it const, it doesn't warn me here that there's a problem. Interesting. So I need to specify var. Individual values can be set with the square bracket notation. Example, this line changes the first prime to 2, which is correct. Okay. And then we have individual values can also be accessed with the square bracket notation. So this is just an access, and we define constant first. Okay, we just extract the value. Great. So problem number 2. Looks like we need to complete this expression. Use the example above to set fourth to the fourth element of Sam Prime's array. So the fourth one will be number 3. Oh, that worked weird. And the problem 3 will be use the length property to get the length of the array. So will be just primes dot, and looks like we have only property length. Interesting. That's literally the only thing we can do here. I guess. I want to also see what it looks like in Z. What if I'm going to run it in Zedit here? Oh. The editor. Here, there we go. Let's move it to a different screen. And I just want to see this one here. Install extension, yes please. Wow, this definitely needs to be larger. So we wanted the arrays. So how it's going to go? Dot. Yeah, length is the only option. Interesting. If I have some primes dot, we have only the size of the array. Huh. What if I want to do something on the number? Can't. All right, we don't have such options here. All right, good. We'll stick to VS Code for now. Okay, so that should work. All should print. So we do zig run 004, and there we go. First, fourth, and eighth. Beautiful. So we can go to exercise 5. Which is continuation of arrays. Okay, so this is going really fast, but I guess we're learning. So let's see where we get to. Zig has some fun array operators. You can use ++ to concatenate 2 arrays. We have one array, second array, and then we end up with a third array, which is A concatenated with B concatenated with yet another array of one element. There we go. You can use double asterisk to repeat an array. Okay, so we take this array 1, 2, 3 and repeat it twice, and we ended up having this. Okay, note that both ++ and asterisk only operate on arrays while your program is being compiled. Ooh, this special time is known in Zig parlance as compile time or comp time. And we'll learn plenty more about that later. Okay, so I guess we can't just get whatever we had during runtime and just go with it. So, all right, so we have those 2 arrays. Oops. And problem 1, please set this array concatenating the 2 arrays above. So it should be 1, 3, 3, 7. There we go. So we do LE ++ ET. Okay. And we have an array of 4 elements. Problem 2, please set this array using repetition. Should be this 3 times. So be 1, 0, 0, 1. And that should be 12 elements, right? Okay, that's all the problems. Let's see the results. And we could print these arrays with all that. Excuse me. But let's have a little preview of Zig for loops instead. So we have 4 and array of items, I guess item array, right? And this is the item. And then in curly brackets, we have do something with item. Don't worry, we'll cover looping properly in upcoming lessons. So a standard debug print, and we just print lead space. And then for, we have that array, and n will be number from that array. It already infers that it's going to be U8. And we print just that, brackets, and I guess they will be replaced with the number. Okay, so it's gonna just print them, right? Nothing else, no spaces between, nothing. And therefore, bits, we'll print them in a way that we again go over bit pattern in here, and we print it the same way. Great. And then we just print new line at the end of everything. So it should be comma, bits, this. Okay. So yeah, let's run it. Zig run 005. There we go. Lead is 1327 and bits is that. Beautiful. So if I would just add space after that, or let's actually do before that, we'll be able to probably print it with nice little spaces. Let's save it. Let's run again. And there we go. We got nice little spaces in between. All right, we're learning. So let's go to 006. So now that we've learned about arrays, we can talk about strings. We've already seen Zig string literals, hello world. Zig stores strings in arrays of bytes. String full equals hello. It almost the same. It's almost the same as constant full list of those characters, right? So it's almost the same. I guess the only thing is like insert type or something. So if I would do just for fun, constant hi is hi. It infers that it's a asterisk const, so a pointer or something to a slice. I guess it's a slice or what is this? Because we have our two elements in 0. And of U8. So we have some extra syntax going on here, all right? And we see similar thing here. All right. So we'll see what Zig strings really are in exercise 77. Oh wow, that's gonna take a while. Notice how individual characters use single quotes, H, and strings use double quotes. And these are not interchangeable. Okay, so we have similar concept that, for example, C# has, and I believe several other languages that I used before, where, double quote is a string, single quote is just a character. So let's see. So we import our standard library, and our main function, we have constant Ziggy, which just holds Stardust. Then we have problem 1. Use array square brackets syntax to get the letter D from the string Stardust above. So D, which we specify will be U8, which seems to be true. So we go Ziggy and 0, 1, 2, 3, 4. Okay. Oh, come on. 4. Problem 2, use array repeat operator to make ha ha ha. So we have so I guess we have create our constant, laugh. And we take our string, which is supposed to be an array, and we need to repeat it 3 times. So we do 3. Okay, that's great. Notice how the type disappeared. The type is unknown. So I guess this might be some problem here. Very strange. This also disappeared. No, this shows it's U8 because we explicitly said it. All right. Problem 3. Use the array concatenation plus operator to make major tom. You'll need to add a space as well. So we have major, we have tom, and we need to concatenate them to add a space. So in theory, we can just do this and a space and this. And if I would make a character, we would try to concatenate a single element with this, right? So this would be probably error if we were trying to do this. Maybe not. Oh, but let's see, because I would expect this to be error because this should be just a single character and not an array. But maybe Zig is smart enough and just does it for us. So that's all the problems. Let's see our results. And we have print D is U, then we have S and S. So D is set as U. Probably for Unicode or something. And an S will be for strings. Okay. So let's see what it does, if it actually runs. Zig run 006 at this point. So we had a problem, just like expected. This is an error. It's supposed to be a string, even though it's just one character, because the string is an array, and we are using this operator to concatenate arrays, not just single characters. So now it should work. There we go. Beautiful. Keen eyes will notice that we've put U and S inside the curly braces, curly brace placeholders in the format string above. This tells the print function to format the values as UTF-8 character and UTF-8 strings respectively. If we didn't do this, we'd see 100, just a number, right? Which is a decimal number corresponding to the D character in UTF-8. And an error because the case of the strings. So yeah, when we look at it, if we're extracting just number 4 of the array of unsigned integers, we just have a number here, right? This is just a number, therefore it would be just a number. Although what happens if I'll just try to do it as S? Error? Yep, error. If we'll do it without anything, it'll probably get the number, right? There we go. If I would do this as without anything, will be just a list of numbers? No, it just cannot form a slice without a specifier. Okay, so basically it's like, oh, we have an array. I don't know what to do with it. All right. And fix that. It's gonna run. Beautiful. All right. So let's maybe do strings quiz. Yeah, let's go all the way to the 8. We'll finish with a quiz, and I'm gonna read a little bit of the book because I want to see how the book goes about teaching us things. So strings 2. Here's a fun one. Zig has multi-line strings. To make a multi-line string, put double backward slash at the beginning of each line, just like the code comment, but with backslashes instead. So it costs 2 lines, and we put them like this here. Okay, and that's gonna be a string. I like that. See if you can make this program print some song lyrics. So the lyrics will be just this, right? And all we do is just to put double backslash. It got a color of a string, beautiful. And this will print as a string, and I guess it's gonna print it as multi-line, right? Okay, yep, that's exactly what happens. All right. Well, that was a short one. So now let's go to the quiz. And we've got a quiz, not a long one. Okay, quiz time. Let's see if you can fix this whole program. You'll have to think about this one a bit. Let the compiler tell you what's wrong. Start at the top. So we're probably tiny bit cheating because we have the Zig, whatever, what do I call it? Language server. So what if I would just do near them and go for the quiz? We have syntax highlighting, so let's move it out to 3. Close this one. And notice that here we don't have anything. We don't have anything when it comes to suggestions from the language server. So this way we're not cheating, right? We're going a little bit more low level. We're using our brain. Okay, so import the standard. That looks okay. Public function main. That sounds good. What is this nonsense? Letters. Y, Z, H, I, F, G. I mean, it's a string. It's a constant. It should be fine. Note. USize is an unsigned integer. Type used for sizes. The exact size of USize depends on the target CPU architecture. Okay, we could have used a U8 here, but USize is the idiomatic type to use for array indexing. Okay, so USize. Okay, I can live with that. There is a problem on this line, but USize isn't it? Constant X, USize is 1. Okay, I don't know the problem. So let's see. Oh, we lost the terminal? Okay, let's just open up here. What was it? Temp, Zig, Ziglings, there we go. Exercises. Yep. So let's do Zig run 008. Oops, 008. So that's not even a problem. Okay. Because it complains about a different line here. So note, when you want to declare memory, an array in this case, without putting anything in it, you can set it to undefined. There is no problem on this line. Okay. So we basically create variable lang. We say it has 3 elements and without putting anything on it. So basically we say it's undefined. So we create an array, we create a memory for it. We can hold those elements, right? But there's just nothing. So I guess it's zeroed at this point. I would presume that it automatically zeroes entire array. And the following lines attempt to put Z, I, and G into the lang array we just created by indexing the array. Letters with the variable X. As you can see above, X is 1 to begin with. Okay, so we have letters. Lang 0 is letters X. Then we have X is 3. Oh, the problem is because we define it as a constant and we try to, change its value here. So what we can do is just make it var, right? Then we have, what's it, lang? Letters X, 1. That will be our Z. Then 3. And we need to do, well, element number 1. Right? And that will be X. 0, 1, 2, 3. That will be I. And that will be 5. Okay. 5 to make it here. Oops. Inside of this, there we go. That was X. Okay, great. So now we want to program in Zig, of course. So standard debug print. That sounds right. Program in, and this expects a string here. And we take the lang. I mean, it should work, right? So let's do save and simply do Zig run. Oops. What the hell is going on? Program Zig. Okay, so we fixed the problem. There was not a lot of thinking here. They suggested that, oh, you'll need to think about it. Okay, that was simple. Sure. All right, so we finished a few basic things. Let's take a peek at that book. Let's see what we can learn from that. It's nearly 12, so I'd say we have an hour. I don't know if I'll survive an hour, especially that there's another stream in the morning. But let's see what we get to. So we were going here, and we have our introduction to Zig. This is very wide, so I'm sorry about that. Welcome, support the book. You can buy it. There's Revolution. Okay. About this book. So we learned about that, about the author. Who's the author? Pedro Duarte Faria has a bachelor's degree in economics from the Federal University of Ouro Preto in Brazil. Currently, there is a senior dot. He is senior. Okay, so we have who he is. For experience in data industry. Okay, so this is just about him, right? Great, awesome. That makes sense. Book compilation metadata, book citation, corresponding author, acknowledgements. Some people helped out. That's awesome. Okay, so let's go into introducing Zig. In this chapter, I want to introduce you to the world of Zig. Zig is a very young language that is being currently developed. As a consequence, its world is still very wild and to be explored. This book is my attempt to help you on your personal journey for understanding and exploring the exciting world of Zig. I assume you have previous experience with some programming language in this book, not necessarily with a low-level one. So if you have experience with Python or JavaScript, for example, it'll be fine. But if you do have experience with low-level languages such as C, C++, or Rust, you will probably learn faster throughout this book. Okay, so what is Zig? Zig is a modern low-level and general-purpose programming language. Some programmers think of Zig as modern and better version of C. In the author's personal interpretation, Zig is tightly connected with less is more. Instead of trying to become modern language by adding more and more features, many of the core improvements that Zig brings to the table are actually about removing annoying behaviors, such features, from C and C++. In other words, Zig tries to be better by simplifying the language and by having more consistent and robust behavior. As a result, analyzing, writing, and debugging applications become much easier and simpler in Zig than it is in C or C++. Awesome. This philosophy becomes clear with the following phrase from the official website of Zig. Focus on debugging your application rather than debugging your programming language knowledge. Yeah, because when I looked at C and asked about the various types of, let's say, pointers, it was just going crazy. Just pointers, right? And that's not even talking on how you're actually using them and making those decisions. Okay, this phrase is especially true for C++ programmers, because C++ is a gigantic language with tons of features, and also there are lots of different flavors of C++. These elements are what makes C++ so complex and hard to learn. Zig tries to go in the opposite direction. Zig is a very simple language, more closely related to other simple languages such as C and Go. The phrase above is still important for C programmers too, because even C being a simpler language, it's still hard sometimes to read and understand C code. For example, Preprocessor macros in C are a frequent source of confusion. Sometimes they really make it hard to debug C programs, because macros are essentially a second language embedded in C that obscures your C code. With macros, you are no longer 100% sure about which pieces of the code are being sent to the compiler. For example, as in they obscure the actual code that you wrote. Yep. You don't have macros in Zig. In Zig, the code you write is the actual code that gets compiled by the compiler. You also don't have a hidden control flow happening behind the scenes. And you also don't have functions or operators from the standard library that make hidden memory allocations behind your back. By being a simpler language, Zig becomes much more clear and easier to read or write. But at the same time, it also achieves a much more robust state with more consistent behavior in edge situations. Once again, less is more. All right, so we again go through basically the same tutorial as we had in our intro. Before we begin our journey in Zig by creating a small hello world program. To start a new Zig project near your computer, you simply call the init command from the Zig compiler. Just create a new directory in a computer, then init a new Zig project inside this directory. So create a new directory, go there and init Zig. Bam. So understanding the project files. After you run the init command from the Zig compiler, some new files are created inside of your current directory. First, a source src directory is created, containing two files, mainzig and rootzig. Each Zig file is a separate Zig module. Okay, so we have concept of a Zig module, which is simply a text file that contains some Zig code. All right. By convention, the main Zig module is where your main function lives. Thus, if you are building an executable program in Zig, you need to declare a main function, which represents the entry point of your program. An example where the execution of your program begins. However, if you're building a library instead of an executable program, then the normal procedure is to delete the main Zig file and start with the root Zig module. By convention, the root Zig module is the root source of your library. Okay, so I've got our tree, right? We have build Zig zon, and inside the source we have those two little main and root. The init command also creates additional files in our working directory, zig build and build.zig and build.zig.zon. The first file, build.zig, represents a build script written in Zig. This script is executed when you call the build command from the Zig compiler. In other words, this file contains Zig code that executes the necessary steps to build the entire project. Okay? So it's interesting that we actually programmed that in Zig as well. I guess Zig all the way. Low-level languages normally use a compiler to build your source code into binary executables or binary libraries. Nevertheless, this process of compiling your code and building binary executables or binary libraries from it became a real challenge in the programming world, once the projects became bigger and bigger. As a result, programmers created build systems, which are a second set of tools designed to make this process of compiling and building complex projects easier. But you need to learn them, right? Examples of build systems are CMake, GNU-make, GNU AutoConf, and Ninja, which are used to build complex C and C++ projects. With these systems, you can write scripts which are called build scripts. They simply are scripts that describes the necessary steps to compile, build your project. Okay? However, these are separate tools that do not belong to C, C++ compilers, like GCC or Clang. Clang, I guess. How do you pronounce it? Clang or Clang? I guess for the compiler it will be just Clang. As a result, in C, C++ projects, you have not only to install and manage your C, C++ compilers, but also have to install and manage these build systems separately. Exactly. In Zig, we don't need to use a separate set of tools to build our projects, because a build system is embedded inside the language itself. We can use this build system to write small scripts in Zig, which describe the necessary steps to build, compile our Zig project. So everything you need to build a complex Zig project is the Zig compiler and nothing else. Great. I welcome this kind of approach. The second generated file, the build.zig.zon, is a JSON-like file. JSON-like, so it's not really JSON, in which you can describe your project and also declare a set of dependencies of your project that you want to fetch from the internet. Ooh. So we have like actual build system, like a package management or something. In other words, you can use this build.zig.zon file to include a list of external libraries in your project. Awesome. One possible way to include an external Zig library in your project is to manually build and install the library in your system. And just link your source code with the library at the build step of your project. However, if this external Zig library is available on GitHub, for example, and it has a valid build.zig.zon file in root folder of the project, which describes the project, you can easily include this library in your project by simply listing this external library in your build.zig.zon file. Awesome. So we have similar approach as Go, where you just can have get your dependencies straight from GitHub without, oh, I'm gonna run clone, go this, remember to update and whatnot. Okay. In other words, this build.zig.zon file works similarly to the package.json file in JavaScript projects, or the pip file in Python projects, or the cargo.toml file in Rust projects. Exactly. Or I don't know, not necessarily. I wanted to compare it to C#, but C# has like two different approaches. You can read more about this specific file in a couple of articles on the internet, and you can also see the expected schema for this build.zig.zon file in a documentation file inside the official repository of Zig. Okay, yep. So that's why I like books, because already all the questions that we had initially whenever we ran the Zig init, we have all the info. It's all nicely described. So great job. I forgot your name. Pedro. Great job. All right. So let's take a look into this root.zig file. You might have noticed that every line of code with an expression ends with semicolon. This follows the syntax of a C family programming language. Yep. Also, notice the add import call at the first line. We use this built-in function to import functionality from other Zig modules into our current module. This import function works similarly to the include preprocessor in C or C++, or the import statement in Python or JavaScript code. In this example, we are importing the standard module, which gives you access to the Zig standard library. So what it sounds like is that standard library actually is massive, I think, because we already had things with arrays, we already had stuff with, like standard output, and probably tons more. I just wonder how far it stretches. In this root.zig file, we can also see how assignments, for example, creating new objects, are made in Zig. You can create a new object in Zig by using the syntax constant or var and then plop a name equals some kind of value. In the example below, we are creating two constant objects, standard and testing. In section 1.4, we'll talk more about objects in general. So yeah, we create constant standard, constant testing, right? And that's it. And then we have some kind of function to add those two numbers together and return them. Great. Functions in Zig are declared using the fn keyword. In this root.zig module, we are declaring a function called add, which has two arguments named a and b. The function returns an integer of the type i32 as a result. Okay, so we have export, which hasn't been explained yet, but we have function named add, and in parentheses we have the two whatever arguments that it takes. And unlike some other languages, the return type is after it. So this is more of a TypeScript approach, and I believe Go approach, rather than classic C standard, which would be to declare type before we name the variable. So I personally definitely prefer this approach. In my opinion, it's way more readable because you can instantly see like, oh, we have A, we have B, and that's it. Functions in Zig, oh yeah, we learned that. Zig is strongly typed language. There are some specific situations where you can, if you want to, omit the type of an object in your code, if this type can be inferred by the Zig compiler. We talk more about that in section 2.4. But there are other situations where you do need to be explicit. For example, you do have to explicitly specify the type of each function argument, and also the return type of every function that you create in Zig. So yeah, I can see that as relatively normal, because, you know, you can consider function to be kind of contract. I give you this specific information, I expect to get this specific information back. Therefore, we need to specify that, hey, if I want to call it, I am supposed to specify int32 as A and int32 as B, right? And whoever called it expects exactly the i32, the 32-bit integer back. And what it makes us is that, hey, this is a rigid contract, so if you make some kind of mistake within your function, you're notified way before it goes out of the definition, right? Because, you know, oh, I returned the wrong thing. You don't have to check if this was used somewhere. You already know that there's a wrong thing. And therefore, you're not risking that whoever's using the function, as long as you don't change the definition, you're sure that it's, you know, that the types are going to be fine. And if you change it, of course, you're going to get a bunch of errors everywhere, but that's to be expected. And that kind of thing is actually used as a tool that, hey, if I'm getting some, you know, if I change this, I don't necessarily need to look everywhere it's being used, because everywhere where this is being used suddenly will most likely start throwing errors because, oh, this thing is not what I expected. Okay, so we went through this. So we specify the type of an object or function argument in Zig by using a colon character, followed by the type after the name of this object function argument. With expressions A i32 and B i32, we know that both A and B arguments have type i32, which is a signed 32-bit integer. Okay, in this part, the syntax in Zig is identical to the syntax in Rust, which also specifies types by using the colon character. Lastly, we have the return type of the function at the end of the line, before we open the curly braces to start writing the function's body. In example above, this type is also a signed 32-bit integer value. And I guess the value is the important thing here, because I expect that we have some kind of concept of pointers and whatnot. We just haven't encountered it yet. Notice that we also have an export keyword before the function declaration. This keyword is similar to the extern keyword in C. It exposes the function to make it available in the library API. Oh, right, because the root.zig is supposed to be a library. Therefore, after you compile it, you're expected to be able to use it within your other Zig or C code, or you could probably use it in most of other languages, because it's just a static compiled library. Okay. Okay. So it exposes the function to make it available in the library API. Therefore, if you are writing a library for other people to use, you have to expose the functions you write in the public API of this library by using this export keyword. If we remove the export keyword from the add function declaration, then this function will be no longer exposed to the library object built by the Zig compiler. And I guess that's different from the pub by the fact that pub is basically, it's published within your module or like, within the Zig language. But if you're actually distributing the thing as a built library, compile library, then you need to export. Okay, makes sense. Wow, this introduction is actually pretty long. I expected it to go a little bit faster, but hey, maybe we're gonna finish at 1.3. Maybe. We'll see, because the time flies fast. There's lots of talking, and my throat might not take it. All right, so the main Zig file. Now that we have learned about a lot, now that we have learned a lot about Zig's syntax from the root.zig file, let's take a look at the main.zig file. A lot of elements we saw in root.zig are also present in the main file. But there are some other elements that we haven't seen yet, so let's dive in. First, look at the return type of the main function in this file. We can see a small change. The return type, so we're not seeing that. So let's actually go and see that. I believe I could probably just put it here on the side. Let's go to temp, Zig, and we had hello world, right? This is exactly the same project. So we can go to our source, or let's just go here and do start new vim, all right? And we can simply go to our source and go to our main Zig file and just go through it. So this should be good enough. First, look at the return type of main. It's not void. Function in this file. We can see a small change. The return type of the function void is accompanied by an exclamation mark. This exclamation mark tells us that this main function might return an error. Oh, okay, so we can basically suggest that, hey, this thing might throw. And now we know. I guess this will maybe force us to handle the error, or will it just suggest it? That's the question. It's worth noting that a main function in Zig is allowed to return nothing, just void, or an unsigned 8-bit integer, U8 value, or an error. In other words, you can write your main function in Zig to return essentially nothing, or if you prefer, you can also write more C-like function which returns integer value that usually serves as a status code for the process. Okay, that's good, so we can, do more communication stuff. So in this example, we return type annotation of main. The return type annotation of main indicates that this function can either return nothing or return an error. This exclamation mark in a return type annotation is an interesting and powerful feature of Zig. In summary, if you write a function that and something inside the body of this function might return an error, then you are forced to either add the exclamation mark to the return type of the function and make it clear that this function might return an error, or explicitly handle the error inside the function, therefore it doesn't throw the error anymore, right? Okay, so we are forced to do that, so that's beautiful. I mean, not with return of void, that's up to, I don't know, caller or operating system, but okay, that's awesome that we can do that. We can force ourselves to handle it. In most programming languages, we normally handle or deal with an error through try-catch pattern. Zig does have both try and catch keywords, but they work a little differently than what you've probably used to in other languages. If we look at the main function below, you can see that we do have a try keyword on the 5th line. So I guess we count 1, 2, 3, 4, 5. Or is it not it? He might be using a different version. You can see below. Okay, I guess this one's the one below, okay? So import this function main, constant standard out, standard IO get standard out writer, and then we have try standard out print. Oh, we have that here as well, sorry. So try standard out print hello something something. Okay. So we have it in line 5. There we go. But we do not have a catch keyword in this code. In Zig, we use try keyword to execute an expression that might return an error, which in this example is the standard out print expression. In essence, the try keyword executes the expression standard out print. If this expression returns a valid value, then the try keyword does absolutely nothing, okay? It only passes the value forward. It's like if this keyword has never, that it's like if. It's as if the try keyword was never there. However, if the expression does return an error, then the try keyword will unwrap the error value. Then it returns, then the try keyword will unwrap the error value. Then it returns this error from the function and also prints the current stack trace to standard error. Okay, so that will actually throw the error and maybe we can handle it above it. This might sound weird to you if you come from a high-level language, because in high-level languages such as Python, if an error occurs somewhere, this error is automatically returned and execution of your program will automatically stop, even if you don't want to stop the execution. You're obligated to face the error, right? Another thing is that you might have noticed in this code example that the main function is marked with the pub keyword. It marks the main function as a public function from this module. Every function in your Zig module is by default private to this Zig module and can only be called from within the module. So what exactly is a module? Is it a file? Is it some kind of namespace? Or is it like mostly multiple files that you can compile as one thing? I'd expect it's just something that can be compiled as a unit, no matter how many files. We'll see. Unless you explicitly mark this function as public function with the pub keyword. Yeah, as function with the pub keyword. Okay. If you think about it, this pub keyword in Zig does essentially the opposite what the static keyword do in C and C++. Oh, really? By making the function public, you allow other Zig modules to access and call this function. A calling Zig module imports another module. A calling Zig module imports another module by using the import built-in function, which makes all public functions from the imported module visible to the calling Zig module. So maybe Zig module is just a file. It starts to sound that way. We'll see. Okay, compiling your source code. You can compile your Zig modules into a binary executable by running the build-exe command from the Zig compiler. You simply list all the Zig modules that you want to build after the build-exe command, separated by spaces. And the example below, we are compiling the module main.zig. So I could probably try it here. What was the way to open it up? I keep forgetting. There we go. No, that's grep. Come on. What was the quick way to do it in your Vim? There we go. So we can do zig build exe and we do source main.zig, right? And looks like something didn't work because I, well, missed the X. Okay. Come on, input, please. EXE. There we go. And now we have the problem. Root source file struct IO has no member named get standard out. Zig's file 12. Did I break something? No. That's a new one. That's just freshly initialized project. Constant starter out. I mean, we're not importing anything anywhere. I mean, on the bottom we import standard, and this is within main, so I guess it should work, right? Ay. Source main Zig 1231 error. Root source file struct IO has no member named get standard out. Interesting. And hello, drunken alcoholic. Long time no see. And do you need to import it at the top first? That's what I was wondering. Do I have to do this? Because by default it's defined here. I wonder if it's to do something with how the build system works. And therefore I should just go and just grab those, right? And we do here and we just paste them. Will this just work? And this was control this thing, right? Yeah, let's try it now. Oh, error expected type expression found a document comment. Oh, I guess document comments are something special. So we grab it from here and we just paste it here. Okay. Huh. So that's what the / exclamation mark is. Document comment. Okay. Progress. This is referenced by call main. Constant built-in. Line. Whoa. Error. Root source files IO. Clear. Doesn't work. Nope. Oh, that didn't clear anything. Error. Root source file IO has no member. So there's no difference. Struct IO has no member. So I guess maybe we have version mismatch. I think I know what's going on, because this very project was created using the version 0.14.1, but we upgraded to 0.15.0, huh? And Drunken says, reading from top down. Unfortunately, I can't suggest anything to help, as I know nothing about Zig except it's the new C, apparently. Yeah. So let's just literally quit this. Okay. Wait, I'm not. Come on. How do I quit this terminal? Okay, I'm stuck in Vim inside the terminal. Exit. Process exited. Great. Oh, wow. Oh. I think I got somewhere. Well, there we go. Oh dear. Okay, so let's remove everything, right? From here. Or let's just do it simpler. Remove hello world. Make directory hello world. And we run zig init, and we should have a new thing, right? Okay, we go to source. And I mean, just here, you have them. And inside build, we should have the main, which hopefully is a little bit nicer now. Wow, this is like vastly different. There's no million comments now. I guess that's the difference with development version. We have standard, we have this stuff, and we are not even running similar code. So yeah, I guess this one will actually compile. So that was the, what was it? Zig something. Zig build dash exe. Yeah. Ha, no module name. Hello world. Available within module main. Great. So I guess this is specifically problem with the, oh, we don't have comment. G C. There we go. I think this is just simply a problem with the fact that we're not going through the build process like this thing was designed for. Underground identifier, hello world. Okay, so this is line 7. Yeah, so this is just an example. I see. So if we were to wait, not this thing. If we were to do this, I think we can just not try to run this command. If we're going to do zig build run, something like this actually runs it and it printed out. All your code base are belong to us, right? That worked. Okay. I guess this is from the time where things were simpler. And Drunker Alcoholic says, did you move to Linux or is it the WSL thing Windows has? This is Linux. I moved full on to Linux. I maybe switched to Windows for a few minutes, a few weeks ago, and that's it. Alrighty. So apparently we can build with this, right? Apparently. I'm tempted to use the word ostensibly, but I'm sure that this works, right? And since we are building an executable, the Zig compiler will look for a main function declared in any of the files that you list after the build exe command. If the compiler does not find the main function declared somewhere, a compilation error will be raised warning about this mistake. Okay, that makes sense. The Zig compiler also offers build lib and build object commands, which work the same way as the build exe command. The only difference is that they compile your Zig modules into portable CABI library or into object files respectively. So we have build lib and we'll build object. Okay, so build lib will be the CABI library, whatever ABI is, and obj will be just into object files, and this is like the, I believe, intermediate of compilation or something like that. And Drunk Alcohol says, congrats, mate. Welcome to Linux and the freedom experience. Oh, yeah, I wanted to switch to Linux for such a long time, but I always had a problem of, oh, I need this, I need that. But I figured there's no way I'm going to do any Unreal Engine development anytime soon. I have 3 separate drives on my PC, so I figured I'm gonna use one of them as just a dual boot, right? And then I know DHH came from Heavens with Omarchy, and yeah, just running Omarchy. So yeah, I have Hyperland, which is like, full on cutting edge. I can just do whatever I want. Yeah, have a nice launcher, everything in here. I can have my little way bar on top. I really like the fact that I can have actual separate left and right screen for stuff. And it was so easy to install. So easy to install. Figured out whatever is Chesmois Chesmois for configuration, so I can have the same thing on my laptop with just a few changes. And yeah, now slowly learning about Linux, how it works, reading one book about Linux, so I learned that hey, your standard input, your standard error and whatever, these are just fake files with 1, 2, 3 handles like that entire system runs, right? That was like, wow. So slowly exploring those things and figured I'm gonna learn Zig instead of C just to gain some more low-level experience. So the idea is that I learned a bit about Zig, maybe make a project with it to learn something more than just reading documentation. Then I'm gonna switch to Python to go on the other extreme and get some real world, like experience with it, because currently I'm looking for a job and everything is like Python. It's like, what the hell? Even .NET developers, Python. Everything's AI, right? And then when you think about it, when you combine the low-level Zig with the syntax of Python, you actually end up with NIM. So I guess I'm gonna make a circle and get back to NIM at some point. Which is just funny. All right, so what did we have here? Does the compiler also offers this? Yep. In the case of the build exe command, okay, as in build executable, right? A binary executable file is created by the Zig compiler in the root directory of a project. If we take a look now at the contents of your directory with a simple ls command, we can see the binary file called main that was created by the compiler. All right, so we've got ls, build zig zone, main and as rc. If I execute this binary executable, I get the hello world message in the terminal as we expected. Main, hello world, beautiful. And Drunken Alcoholic says, nice, very cool. Yeah, I'll be all on board with your Python series. Yes, exactly. It seems NIM is the child of lower level cross with Python. Yep. I know that the syntax is inspired directly by Python. Everything else is very, very, very C influenced. That's why I was struggling so much with NIM, because there's just so many low-level edge cases that I have no idea where they're stemming from. Like, why? And I'm hoping now I'm going to learn a little bit more. Not directly C, but something of the sort. Okay, so basically when we run the main file, it runs, right? Great. So then we had the fun part, compile and execute at the same time. In the previous section, I presented the Zig build exe command, which compiles Zig modules into an executable file. However, this means that in order to execute the executable file, we have to run two different commands. First, the Zig build exe command, and then we call the executable file created by the compiler. But what if we wanted to perform these two steps all at once in a single command? We can do that by using the zig run command. There we go, zig run source main zig. And I'm sure it's gonna simply fail. Come on, I want input zig run source main.zig. Yep, the same problem because we import hello world, which is whatever. Yeah, not imported properly. I guess if we were to look here into build.zig, we'll probably have some more important, like something that would work a little bit better. Oops. Okay. I haven't used NeoVim extensively for a long time, so I'm just discovering the quickly shortcuts. So we have our Control Shift. Oh no. Don't remember how to move one line by one line while moving the entire screen. That's the thing I'm missing. So in our build script, we do target is standard target options, standard optimize options, great. Then we have add module, hello world. So we add this module from the root.zig file. Okay. So that's our module. Then we define the executable, which will be add executable, hello world, create a module from, oh, look at that. So we have a root module, right? That we specify that's our main Zig. Everything, whatever, because it's a executable, we optimize it, all that fun stuff. And it imports, so here hello world is the name. So we basically add our hello world module into here. And that's why it works in build time. Then we install artifact or whatever, run step, run the app, and do a bunch of other magical stuff that I really don't care right now. Okay, good. At least we're able to read through it, right? So that's nice. The build scripts are in Zig itself too. You don't need to learn any other tools. Lovely. Okay, important note for Windows users. First of all, this is a Windows specific thing and therefore does not apply to other operating systems such as Linux and Mac OS. In summary, if you have a piece of Zig code that includes some global variables whose initialization rely on runtime resources, then you might have some troubles while trying to compile this Zig code on Windows. An example of this is accessing the standard out, for example, the standard output of a system, which is usually done in Zig by using the expression standard IO get standard out. If you use this expression to instantiate global variable in a Zig module, then the compilation of your Zig code will very likely fail on Windows with an unable to evaluate compile time expression message. Something tells me this is no longer the case because we already have here in the main Zig page, go to main page, comp time emulates the target architecture, but maybe it's just architecture. Oh, it's probably just architecture. Oh, it's ARM or something else. It doesn't emulate the target as in Windows or whatnot. Very interesting how true that thing still is. If it changed, because it just changes so rapidly that, yeah. This failure is the compilation process. This failure in the compilation process happens because all global variables in Zig are initialized at compile time. However, on Windows, operations like accessing the standard out or opening file depend on resources that are available only at runtime. I actually really want to try it. I want to see what happens on Windows. Let's see if I can spin up quickly a Windows VM. Okay. We'll see if that works. Yeah, we'll let it run. In the meantime, we can read further. So for example, if you try to compile this code, example in Windows, you will likely get the message exposed. So we have standard import error. Compile time error has emerged from this next line because in theory, the Windows doesn't have the standard output the same way Unix systems do. And you could have problems. You would probably need to do something else, but maybe it's abstracted away already. I don't know. Yeah. Unable to evaluate comp time expression BLK ASM. Yeah, because this is constant, so therefore if it's a constant, it's compile time, and it's like, oops, nope. To avoid this problem on Windows, we need to force the Zig compiler to instantiate this standard out object only at runtime instead of instantiating it at compile time. We can achieve that by simply moving the expression to a function body. This solves the problem because all expressions that are inside a function body in Zig are evaluated only at runtime, unless you use comptime keyword explicitly to change this behavior. You will learn more about this comptime keyword in section 12.1. There we go. We run it still as a constant, but inside a function, and we learn that inside a function, unless explicitly said, it will be runtime. Okay, good to know. You can get more details about this Windows-specific limitation in a couple of GitHub issues open in the official Zig repository. Okay, good. Let's look at the VM if it started up. Yes, it started up. We've got a clean system, so we can quickly check how to install Zig on it. Let's get started. We had installing Zig on Windows. With package manager, we can just use winget. Winget install -e id Zig Zig. Okay, let's try that. Terminal. And we'll do winget install whatever -e is for --id. Yeah. What? Zig.zig. Alrighty. We got version 14.01, which is fine. Alright. So while this is loading, we can go back to our book. Because I'll need to finish in 15 minutes. Okay, so compiling the entire project. Just as described in section 121, as our project grows in size and complexity, we usually prefer to organize the compilation and build process of the project into a build script using some sort of build system. And the Drunk Alcoholic says, apparently you can compile nim with the Zig compiler. Yes, and I did that because I didn't feel like installing a bunch of stuff. I actually did that on Windows. Well, out of all places. So yeah, you can do that. And it works. Because yeah, nim is written in C. And actually, fun fact, when you compile nim program, it first compiles down to C and then it compiles C. So it's not like immediately from nim to executable, it just compiles down to C. At least that's what I recall. Maybe I'm wrong. Okay. In other words, if your project grows in size and complexity, the build, exe, and other build commands become harder to use directly. Because then we start to list multiple modules at the same time. We also start to add built-in compilation flags to customize the build process for our needs. For example, it becomes a lot of work to write the necessary commands by hand. In C, C++ projects, programmers normally opt to use CMake, Ninja, Makefile, or configure scripts to organize this process. However, in Zig, we have a native build system and the language itself, so we can write build scripts in Zig to compile and build Zig's projects. Then all we need to do is to call the Zig build command to build our project. So when you execute the Zig build command, the Zig compiler will search for the Zig module named build.zig inside your current directory, which should be your build script containing the necessary code to compile and build your project. If the compiler does find this build.zig file in your directory, then the compiler will essentially execute a Zig run command over this build.zig file to compile and execute this build script, which in turn will compile and build your entire project. Bam. So we saw that in action. After you execute this build project command, a Zig out directory is created in the root of your project directory, where you can find the binary executables and libraries created from your Zig modules accordingly to the build commands that you specified at build.zig. We will talk more about the build system in Zig later in this book. So I don't think I have it yet. No, I can't do that. Oh yeah, we have Zig out, we have bin, and we have the hello world. Okay. I wonder if I'm going to just do Zig build, and that's it. Oh, it doesn't even bother. I already did that. Okay, makes sense. Alrighty, let's check on Windows. Successfully installed. We have Zig. So let's go to, I mean, we need to restore the terminal. That's, otherwise we won't have that. Zig version. Thinking. 30 years later, maybe, yes, we have the Zig version. Beautiful. What do we have here? Documents, downloads. Let's literally go to downloads. Or wait, we have the B drive. There we go. There we go. Make directory temp/zig. Temp/zig. Okay. And we can go, yeah, nothing here. Okay, ls is built in, but not parameters. Okay. All right, so we go zig init. Will that work? Okay, we got the stuff. Beautiful. I just realized I don't have code editor here. Oops. We're gonna go something crazy. I need to see the code and make it break or whatnot. So we're going to go to this PC, development drive, temp zig, and we have our files, right? So we want to go to our main.zig, because if we were trying to, I see. I mean, it should build nonetheless. So if I'll go here and do zig run, zig build run. That should work, right? It's thinking, and we should get some kind of something working. Takes the time. All right, so we got stuff printed out, right? No big deal. So now let's try to change it into that static thing. Our main zig, and we're going to go with open with Notepad. Oh wow, this would be our main editor. Holy moly, we got Microsoft account in your data. Go away. Notepad automatically saves your progress. All your note content will be available next time you open Notepad. Look at that. They upgraded everything by now. We even have Copilot to help us code. We don't have syntax highlighting, right? No, we don't have that yet. Can we do Ctrl plus to increase font? Look at that. Beautiful. That is so funny. So what were we doing here? We had our main, and we were just doing straight up debug print. And we have IO buffered writer, all that worked. But what was the example in the book? We had this standard import main, and we wanted to do this to write hello world, right? So let's maybe add exactly this part that we just want to write hello in this way. I want to see if this will work. So after everything happens, after we finish with our writer or whatnot, we will just, oh, I can't paste in from, that's the one thing that have worked. Constant standard out is standard IO gets standard. How about we'll just bring it, no, here, okay. There we go. That should make it easier. Constants std out is std.io.get standard out writer. Anything else? just finish the line. And then we have try standard out right hello /n to escape it, and that's it. So when we save this, we should be still able to build and run, and it should go well, right? Wow, compiling takes time. Nope, it doesn't. Standard out. Do I have it defined somewhere already? Standard out is for the actual standard out file and all that stuff. Oh, constant standard out. So let's do standard out 2. There we go. That should solve our problem. Oh, nope, still not. Exit code 1, standard out BW writer. Now this has a problem, but we just renamed it. We shouldn't have that problem anymore. Oh, no, wait. Oh, beautiful. Very visible, right? It worked. We got a hello. Okay, sorry about that. So now the idea is that we move it outside of here, where our standard out 2 will be just compile time. And now we got an error. Yes. Got an error. And the error is build debug native errors. Unable to evaluate compile time expression ASM. That's it. So we still get that problem. All right. So, yep. We confirmed this is still not very exciting to just get an error that you expect, right? But okay, just in case, we have Zig running here on this box, and we can use it in the future. All right. So we'll shut this down and get back to our thing, because I think we are nearly finished, right? So with C++, yeah, we need to have those big things, but build will we'll be searching for the build Zig, and it will run everything. So after you execute this build project command, a Zig out directory is created in the root of your project directory, where you can find the binary executables and libraries created from your Zig modules accordingly to the build commands that you specified. We'll talk about it later. In the example below, I'm executing the binary executable named hello world that was generated by the so we just get hello world. All right, so next thing will be actually in the book, we'll be learning how to learn Zig. So yeah, let's just read the first tip. What are the best strategies to learn Zig? First of all, of course, this book will help you a lot on your journey through Zig, but you will also need some extra resources if you want to be really good at Zig. At first, as a first tip, you can join a community of Zig programmers to get some help. Okay, we've got Reddit. I'm not going there. Zigit community. It's interesting. And Discord, Slack, Telegram, and others. Wow. Now, one of the best ways to learn Zig is simply read Zig code. Try to read Zig code often and things will become more clear. A C programmer will also probably give you this same tip because this strategy really works. Now, where can you find Zig code to read? Personally, I think the best way of reading Zig code is to read the source code of the Zig standard library. That's actually a great idea. The Zig standard library is available at the lib standard folder on the official GitHub repository of Zig. Access this folder and start exploring the Zig modules. Also, a great alternative is to read code from other large Zig code bases. So let's see. All right, so we have Bun, great. We have the game engine Mac. We have Llama 2 LLVM model implementation in Zig, interesting. The financial transactions database, Tiger Beetle. Oh yeah, Tiger Beetle, that will be interesting. I expect that to be top notch. The command line arguments parser ZigClap, the UI framework Cappy, the language protocol implementation for Zig ZLS, and the event loop library libvex. Oh, interesting. So we can kind of throw in an event loop into our software. Cool. All these assets are available on GitHub, and this is great because we can use GitHub's search bar to our advantage to find Zig code that fits our description. For example, you can always include langzig in the GitHub search bar when you are searching for a particular pattern. This will limit the search only to only Zig modules. Great. Also, a great alternative is to consult online resources and documentation. Here's a quick link, a quick list of resources that I personally use from time to time to learn more about the language each day. Okay, so just the language reference, standard library reference, the Zig guide that I dismissed several times already, Carl Sagan blog, Zig news. Oh, that's fun. I'll click on that. Read the code by one of the Zig core team members. Okay. And some live coding sessions are transmitted in the Zig Showtime YouTube channel. Look at that. Another great strategy to learn Zig, or honestly to learn any language you want, is to practice it by solving exercises. So for example, we have the Zig links we already tried. We solved 8 of them, which contains more than 100 small exercises. It's a repository of, and a famous tech YouTuber known as the Primagen also posted some videos on YouTube where he solved some exercises from Zig links. Yep. Another great alternative is to solve the Advent of Code exercises. That will be actually fun. It will be really fun to go through all the Advent of Code exercises from back, long time ago. There are people that already took the time to learn and solve the exercises, and they posted their solutions on GitHub as well. So in case you need some resource to compare while solving the exercises, you can look at these 2 repositories. Beautiful. Okay, so we went through the whole next subchapter, how to learn Zig. So don't know when. I'm not saying that I will be doing the same thing, every morning I'm streaming one thing, every night I'm streaming another thing. Now this is just a random thing. So your next stream of Zig, don't know when, we'll continue with the book and with the Zig links exercises, because so far I like the book. It goes in enough depth so far. We'll see how deep it goes in other parts, but this introduction, we're just 1/3 through that. I mean, we didn't learn that much from the syntax or whatnot, but we have the basis laid out for us to, guess less as we go on, right? So that's awesome. So, yeah. Thank you everyone for watching, and I will be finishing for tonight. So thank you. Have a great day. Have a great night. And thank you for tuning in, Drunk Alcoholic. And see you next time.